Birds' nests vary a lot. From the massive holes that malleefowls dig in the ground to oven birds who are literally named for their pizza oven style nests. And most of the time, it's pretty straightforward to see why a nest is built a certain way. Say you're a crested auklet living on the old lava flows on the Aleutian Islands of Alaska. You're probably not going to find many leaves to help build your nest. Or maybe you're a toucan with a beak up to 4 times the size of your head. That makes it pretty difficult to maneuver tiny sticks into an intricate nest. Scientists have tried, as scientists do, to develop a general explanation for bird nest variety, but they keep running into trouble because there's just no perfect way to explain all those unique styles. All birds lay their eggs in a nest of some kind, even if it is super basic. And many species of chicks tend to hang out in that nest for a while after they've hatched. Despite the many forms nests might take, we can generally think of them as a cozy little container that protects future chickies from the rough, wild world out there. That means survival, in part, depends directly on the nest. So, nests are a prime target for our friend evolution to modify their shape based on environmental pressures like climate, foliage type, or predators. Like we saw with the crested auklet and toucan, birds are constrained by the available construction materials and by their anatomy. And some species, like the Siberian jays, will build their nest in a covered area if they think there's a high chance of predators swooping in to snatch an egg. So far, so good. These examples make sense. But of course, we know that nature isn't as simple as, oh, sticks, I'm gonna make a nest out of sticks. So once scientists start searching for common factors between lots of different nest styles and across many species and environments, it gets trickier. What we would love to understand is how all those environmental factors, climate, predators, material availability, influence a nest's location, shape, size, and how it's attached to external structures. But even trying to explain different nest styles within similar environments can be tough. For example, northern gannets and black guillemots both nest on similar rocky cliffs on the British Isles. The northern gannet builds huge nests up to 1 meter tall to support their eggs on the precarious cliffside. On the other hand, black guillemots just try to wedge their eggs in a crevice, or they plop them in an abandoned puffin burrow. While the location, building materials, and predators are mostly the same for both species, they've ended up with vastly different nests. It might seem that researchers have set themselves too big a task by trying to understand all bird nest methods. It seems too varied a problem to explain with just one hypothesis, but it's pretty common in evolutionary biology to search for these kinds of patterns using a statistical method called multivariate phylogenetic analyses. So that's exactly what one study from 2025 tried to do. But before I can tell you about what they found out, we've got to keep our nest funded, so here's a quick ad. You watch SciShow, you're curious about the world and the universe you live in, you think it's good to learn new stuff whether you're in school or not, and you'll do it all online if you can. If you're the average SciShow viewer, you're also the average Brilliant subscriber. Brilliant is an online learning platform made for everyone from age 10 to 110. They offer courses like the Digital Circuits course, which includes step-by-step interactive lessons and personalized practice opportunities built in. So you can learn by doing. To learn for free on Brilliant for a full 30 days, go to brilliant.org/SciShow, scan the QR code on screen, or click on the link in the description. Brilliant's also given our viewers 20% off an annual premium subscription, which gives you unlimited daily access to everything on Brilliant. Researchers collected data about nests from as many species of birds around the world as they could, as well as information about the environment for each one, and created a huge dataset. Then they used statistical analyses to make a model that could explain bird nest variations based on factors that could be driving the evolution of those traits. Things like climate, potential predators, or whether or not the birds lived on an island. Remember, surprising evolutionary stuff happens on islands. But their model could only find evolutionary explanations for about 4% of the variation in birds' nests, which is Not a lot. Climate could explain around 2.5% of nest variation, according to this model. This mostly came down to whether the environment was dry and windy or cold, wet, and still. In the dry and windy case, the harsher environment tends to drive birds to build their nests in cavities, like the mountain chickadee or an underground burrow like Leach's storm petrel. Researchers could explain another 1.6% chunk of nest variations based on the combination of kinds of vegetation nearby, predator presence, and whether the birds are on an island. We are really splitting hairs here, folks. That universal bird nest model clearly did not find many overarching themes. You might be thinking that there must be some unifying factor missing from the model, since it's not finding many useful connections. Perhaps birds that are more closely related have similar nests, or maybe their position on the evolutionary tree comes into play. But it turns out relatedness also wasn't a great predictor of what a nest might look like. Take the group Furnariidae, those cute little fellows with the pizza oven nests. Even though species within this group are closely related, being in the same genus and all, these birds can be found in all sorts of different environments. They live anywhere from rocky shorelines to deserts to alpine areas and deciduous forests. Their nest diversity reflects the range of their environments. They make nests of mud and plants, or cactuses, or spiderwebs and grasses, sometimes inside a woodpecker hole or a burrow deep in a cliff face. So a lot of different real estate options for ovenbirds. Since ovenbirds kind of throw out the relatedness hypothesis, researchers pivoted to thinking perhaps nests are an all roads lead to Rome situation. Like, if conditions are broadly similar, then maybe it doesn't matter too much exactly how birds protect their eggs, as long as they survive. Remember those northern gannets and black guillemots we mentioned earlier? It probably helps that their eggs aren't totally helpless victims to their surroundings. The embryos inside the eggs can cope with some of the fluctuations going on outside their cozy confines. These eggs can withstand temperature swings of up to 20 degrees Celsius in a single day. So it's not as important for the nests their parents build to be perfect. And there are a couple other factors that could be making it so hard to explain nest variety. For one, in most studies, researchers talk about the environment as the fairly big space that the nest sits in. But the scientists in the 2025 study say that maybe the area just around the nest or its microenvironment is just as important as the broader environment. It's not too hard to imagine that when it comes to hiding from predators, how tightly packed the tree branches are around a nest might matter more than how many trees there are in the forest overall. We can also look at the Tibetan ground tit as an example. They nest in pre-made pika burrows, in crevices, or in burrows they build themselves. At least one study found that within the same habitat, Tibetan ground tits change the shape and entrance size of their burrows depending on how windy and cold their particular patch of tundra is. If their burrows faced the strong afternoon winds, they'd have a longer entrance tunnel to keep warm for longer. Whereas if they were facing the sun, they'd build shorter tunnels to pick up as much heat from the sun as they could. But unfortunately, microenvironment information isn't captured in big databases like the ones researchers used for the Big Nest survey. Other scientists have suggested that nest building could be a form of culture for birds, and that there's an element of creativity to building. At least one study found that individual zebra finches build nests with their own sense of style. These birds choose different materials based on preference, say for a particular color or due to constraints of their microenvironment, like selecting shorter fibers to fit through a narrow nest box hole. But maybe the biggest thing that the scientists learned from this story was that we haven't actually been very good at describing nests. There's tons of glorious nest nuance out there, but it just hasn't been captured by the broad, standardized descriptors that scientists have been using for years. So, for now at least, scientists don't have a unified theory of bird nests, but with a little more searching and some better vocabulary, we may one day weave together an explanation.